Tonight we're going to speak about TDD, test-driven development for IaaC, for infrastructure as a code, and is it going to be the future trend or not? So, let's see. So, привет. And I'm Gianfranco. I've got a PhD in automation engineering, and I've been one of the first early adopters of Linux when it was installed on 57 floppy disks. And you were going to the university and you were downloading 57 floppy disks. You were coming back home and you were trying to install it, and the 53rd or the 54th was broken. So you had to go back and re-download the whole stack. And but this didn't discourage me, so I'm still loving Linux a lot. And well, since then I've done quite a few things, and so now I call myself a DevOps architect, even if my company is calling me systems architect or cloud architect. And well, I worked in a few countries. In Italy, not a great country to work in Canada, boring, in the UK, then in Sweden, then in the UK again, and then I had the opportunity, because that fantastically looking guy there with the fantastic, that one, Kirilla, gave me the opportunity to come to Ukraine, and then I said, I really want to go and work in Kiev. And so we had a very interesting conversation, and he ensured that I was really meaning Ukraine, and yeah, I meant Ukraine. So I'm here and happily sitting in Kiev. And so this is it. Wow. About you guys, one thing that I would like to assess is how many, if you can actually raise your hands, how many of you are developers? Can you raise your hands, the ones that call themselves devs? Okay, thanks. How many of you are ops, are sysadmins and people like, cool. And how many out of you are DevOps, and they're calling themselves, they kind of the same of the ops, okay. And how many of you coming from testing? No testers, it's bad word. No, nobody says, okay, it's bad, testing is good. Now we're gonna see how cool it is. Okay, it's too serious. Okay. So yeah. So well, I'm actually trying to evangelize people about how to do DevOps in a proper way, because it seems that in many countries they don't know how to do DevOps. In some countries, like the UK, they were trying to do less DevOps because we cost too much. Instead of seeing the nice part of we actually automate things, so you actually pay us, yeah, a lot. Well, good. We do difficult stuff. But then you get rid of us. No, they actually think you cost too much. And so in some companies, they're like, well, let's make the devs learn how to do DevOps. Let's turn the devs into DevOps, which is not exactly the way to do DevOps. So we will see why, because we do different things, and we're pretty proud of doing different things. And so, well, let's step on, because it was getting boring now. So why testing infrastructure as a code? Infrastructure as a code is, well, I give a description of the infrastructure that shall contain my application, and I am actually deploying this description to a cloud provider, to a simulated cloud provider, and blah, blah, blah. And, well, this spins up, and so, well, I've got error messages and non-error messages if the things goes on. So why shall we test infrastructure as a code? Well, first of all, we can say, why aren't we already doing it? Essentially because infrastructure testing is something that is a problem of nobody. There is a cultural problem, is a subject which is in between devs, in between ops, in between tests, and is a responsibility of DevOps, is it really? I mean, so nobody's taking this as his own responsibility. So why shall I bother? Nobody's asking me to do that, no? No, we shall bother. now we see why. First of all, because infrastructure as a code is becoming more and more complex the more the project grows. And this tends to become more complex no matter what the application is looking like. The application can grow and scale, and yeah, we do architectures that scale. This is the meaning of the cloud. But the problem is the application scales linearly or just parabolically, and infrastructures tend to explode in complexity and grow faster. We will see why in a few minutes. Another point is we demand devs to be strict and to write tests. So we stress them. I already see the Scrum and all the times that somebody is actually telling, hey devs, more tests. And we are like, they hit the devs, more tests for them. And yeah, guys, this is a problem also for us, you know, DevOps is a, well, we have to test, we do infrastructure as a code, we do infrastructure development, so we shall put some salt and test in what we do. And the problem is the tools are horrible. As for now, the tools are really not sharp enough. We will see that there's a lot of hacking that is required to get to a point to have a deployable TDD IaaC. But well, we are cool. We can hack stuff. This is all what DevOps is about. So, you know. Also, the other problem is sometimes we design architecture so that they are not accessible. They are not testable. Well, they might be monitorable, but sometimes the whole architecture is designed, for example, immutable architectures are designed not to be easily accessible by testing, by design. And so how do we address the problem? Well, the solution we'll see is the same solution that we would have as devs, which is let's address the problem the soonest, because the soonest I address the problem, the easier it becomes to actually propagate the coverage onto the infrastructure that gets deployed. Big problem is that there is a very low ROI on TDD IaaC because nobody knows what it is and what it is for. And so your program manager, your product manager, your PO, whatever, want to know why is investing some budget of the project into making this testable. Well, go and tell them what you're gonna see tonight, and probably he will be so happy of investing a couple of weeks of your work into making things testable. So this quote is confidence in code without tests is false confidence. Buddha in okay, well, this is clearly a joke, but if he knew about infrastructure as a code, he would have agreed. So the point here is that what is most important is not what the code is meant to be, but is what the code really does. And we will see that with the cloud, this can be a problem. The problem is the cloud is designed so that I give instructions to an engine written by somebody else that is receiving the instructions and says, okay, good, I'll do. And then we have no visibility of what is happening. Well, we will see this is called the 200 effect. And well, we have the fake impression that our tools, that our Puppet some years ago, that the Chef, Ansible, Terraform, CloudFormation are doing exactly what we tell them to do, which is totally wrong. So what are the typical infrastructure as a code problems, caveats? So the first, I've already mentioned a few minutes ago, is the 200 paradigm, which essentially says stack deployment in the cloud is something that is a request, is a polite request to a REST API to can you please spin up this machine for me? And the REST API is answering us, yeah, of course, 200, all good, copy that. And then, well, the snapshots don't don't get snapshotted, and the instance doesn't come out, that doesn't come up, and the auto-scaling group is bound to nothing. And well, a lot of things can happen that hadn't been taken into account. So clearly, in some situation, we don't even have the visibility because, well, I'm trying to snapshot an RDS instance. Okay, come back in a few minutes. How many minutes? I mean, it depends strictly on the size of the instance. And so I don't even know how long shall I wait to actually go and ping the server to check, hey guys, what's the status of the request? Yes, there's a percentage, but you know how these days percentages work, you know? It's not only these days, yeah. So this is the 200 paradigm, the HTTP 200. Yes, I'll do, yeah, but come back later. The second problem is, well, cloud providers are making changes, and they are improving their offers, and they are making things smoother, and for your benefit, they are changing a lot of stuff, such as new instance types, good or bad, both. They changing the length of some identifiers. Sounds familiar to AWS guys. They changing the SSL certificates for some strange service. Okay, what you have deployed yesterday, you would Terraform again, and you should have a Terraform plan which is empty, because, wow, I deployed it yesterday, nothing has changed, and you come out with a Terraform plan which is 5 pages of plan. And you're like, what the heck, what's going on here? I did nothing. Amazon did. I mean, Bezos has to do something, so, or Gates or whatever. So this is also a problem. We rely on things, and just because we gave a description once, it doesn't mean that, well, this stays the same tomorrow. Something can actually change. Also, we have to talk about, well, the problem of collaboration. I mean, infrastructures scale. Well, I'm the coolest DevOps in the universe, so I'm doing the big projects, you know, and tomorrow there's another DevOps that is actually doing another part of the project. We have to coordinate, and some of our tools are horrible in coordinating the effort of multiple DevOps. I mean, let's talk about, okay, now we have shared backends, and we can actually share the state files in S3 buckets, all right, with Terraform. But how many infrastructures have you seen destroyed because the A guy was using Ansible, the other one was using Terraform, and the other one was trying to do something with CloudFormation? And this is already, you know, bad because 3 technologies. Now everybody knows that you don't have to mix and match the technologies, but you can make a lot of damages even just using the same technology. So collaboration doesn't really work well unless it's strictly coordinated. We see that this has to be tested as well. Then we have other problems. The problem that, well, Dimitri is going to talk you in the second presentation of tonight, which is, yeah, deployed something and works too much. Well, I was supposed to have port 443 open. I've got 65,535 ports open. It's not exactly safe, not exactly secure. So I have to test that I have deployed exactly what I want and not more. And this also needs to be tested. This also needs to be tested for 2 reasons. One is security, the second one is billing, because sometimes I'm just leaving behind some instances that have been formed with some other tool, and what am I doing? I'm writing a Lambda that is enumerating all the instances that are remaining there, orphaned, and yeah, well, this is a classic problem that can be addressed with the tagging. So generally we tag the instances with the version of the script that is actually generating each instance, so that we can actually make a loop enumerating the instances and kill the one that are older versions. But you know, we have to think about this, and this is also testing infrastructures. So yeah, a lot of things can go wrong. There's a lot of things that can time out. There's a lot of things that are depending from other things. And yes, some tools are smart enough to decide the priority of the operations. some other tools are not, so yet another thing that we have to test. So, infrastructure as a code means that we have to apply software development lifecycle methods and the tooling, the same toolings, to infrastructure development. And this is a big statement because, first of all, it turns us into developers. Infrastructure developers, i.e. developers. Okay, we might not do OOP programming, but we do still have Turing-complete languages like Python, like Ruby. And, wow, it's so cool having Python and Ruby. Guys, I still remember the times of just having to Perl stuff, which was just awful. And, well, when we started CVSing stuff, and then we started putting Puppet into Git, wow, this was already kind of good day. And, well, now we actually have reused a lot of the technologies of the devs, and we can do better than them, really. It's like, trust me, we are really, really doing awesome, which is, we use Turing-complete languages, like Ruby and Python, and we create a description of infrastructures with the incomplete description languages, like ACL, Terraform, and like JSON and other stuff, which are just descriptive languages. And then we go and tweak them with other languages, like Ansible. Don't you see how elegant this is? I mean, this is something that, well, probably to a dev is looking quite creepy because we're using 3 technology on the stack of each other. But no, it's really elegant. It's really, I don't know how to describe it. You should know. You probably do it yourself. So what we are doing here is we create a parallel CI/CD pipeline that is stuck in on top of the CI/CD pipeline of the developers. So they develop their code. Thumbs up. They're really cool. Maximum respect for devs. They do a really tough job. And when I see some code in OOP languages, I'm like, okay. But you know, we do another job, which is we provision the stuff for them to actually host their stuff. And, well, now we do it with the same technology, and not just. They have their own pipeline. We have our own pipeline. And they have their own progression of status, and we have our own progression of status. Now, the problem is they must go and be sync. Because if they go at different speeds, you know the phenomenon of beating. They beat. The 2 wavelengths that are actually provoking a beating. So we have to do so that we are synced with the pipeline of the developers. So we have to learn from our beloved developers. What we have to learn from the devs is what are they using to actually develop their code in a fast and efficient and fully testable way, which is something that seems that nobody is doing currently, even in big companies with infrastructure as a code. So to do that, we use the TDD loop. The TDD loop is test-driven development, which is essentially this fantastic 5 steps loop, which says, think of a behavior, then write a test which fails, then write just about enough code to make the test pass, and then refactor. I think to another behavior that will actually make your function work. So this doesn't make that much sense as I just say, but the thing is, well, we can actually make an example. The example is, I want to make a function that is testing how strong a password is. So I hope that you can read from behind, but otherwise I'm actually give you some clues about it, which is, first of all, I think of an expected behavior. I want a function, so I'm actually writing the description of the function, which is strong, is a variable, possibly Boolean, that is telling me whether the password is strong and is having a string as a parameter. then write a test that fails. So the first thing that I might think is, well, what is the possible stupidest, silliest, disgustingest password that I can think about, which is the null password. So I write a test that says, I describe, this is the description language for testing, I describe a test that says, okay, if the password is null, the function must return false. Okay, I write this test that fails, and then I can actually write just about the code which is necessary for this test to actually be passed, which is, well, if not password, then return false. Wow, fantastic function, is great. But this gives you the idea that now is the moment to refactor. So refactoring is also meaning, okay, let's think again. Okay, now I want to do it again with passwords whose length is less than 12 characters. And so I reiterate this, and I do it with passwords that have numbers and all other stuff that you might think about. So TDD is keep it simple, and how can apply this to infrastructure as a code? Well, I know it's boring. This is the boring part of the presentation. Okay, all things that we all know. Yeah, the pyramid of test pyramid. Oh no, how many times have I seen the test pyramid? But this makes sense here. This makes sense here because now finally we have a test pyramid which applies to infrastructures. So finally something that competes to us, you know, not something that. So infrastructures. So we see that at the bottom of the pyramid, which is unit testing. Unit testing is tests that are quick, dirty, and they're just cheap, just because they're fast. And they just tell us the answer to questions like, am I missing some best coding practice? Or do the CD scripts work? Or is my code style decent enough for another infrastructure developer to be able to read it? Am I using the same formatting rules that we have decided at the beginning of the project? And am I committing rubbish into the repository, or I'm actually committing something that is readable, because, you know, good code is maintainable code? Am I actually solving the right problem? Because how many times we actually started writing code and then we were like, that's cool what I just wrote, but doesn't solve the problem, it solves another problem. I hope that one day I will have that problem. So in this case, the thing is, well, unit testing, and unit testing is nice and can be very easily integrated in your CI/CD pipeline, both the one for the devs, but more in detail in the one that we're gonna use, which is the CI/CD pipeline for infrastructure developing. So the second kind of tests is integration tests, which still applies to us quite a lot. And as you can see, answers to the questions of are the instances up? And can they connect the DB or the load balancer or the other pieces of infrastructure that we are meant to connect to? This integration test, well, let's finish with the acceptance tests, which are tests that are answering questions like, is the Bastion host, for example, up and running and allowing me to connect? So this means that the firewall rules must be in place, the VPN must be in place, and blah, blah, blah. And how's the security of the VPC? I mean, things that are really inherent to the deployed architecture. So we can see that the red part of the pyramid is something that needs the architecture to be production-like, instantiated, converged, in place. So I cannot run acceptance, smoke, penetration tests on something which is just virtualized. Whereas when you're speaking of integration, well, integration is something that we can do on nicely simulated infrastructures. I'm speaking of Vagrant and some infrastructures which are simulated in a proper way, and we're going to see that there are some tools that are helping us test onto simulated infrastructures. Whereas at unit level, we don't even need to run the code. because it's just static analysis, and so we can actually just, based on some nice scripts, have already the idea whether this is going to work fine or not. Now, the problem that we have as infra developers is that when we spin up an infrastructure, it costs us a lot. So we want to limit the expensive tests just to the end of the chain, and of course we want to maximize the utilization and the coverage of the unit testing. So this is just a recap of just what I just said. Probably I spoke too much in the previous slide, and now I should just shut down. No? Okay, but the thing is, in unit testing, no test is actually run. So we actually verify the internal consistency, the style, the use of variables, intrinsic language constructs. In integration, we actually run the code, but we don't run it onto the real cloud environment. We actually run it onto a simulated environment. We actually converge in the infrastructure, but not in the real place where the infrastructure will be hosted. The result of the integration code is actually validated, and we can already start some functional testing and end-to-end start testing, because we actually have the boxes and we actually can connect the boxes. They simply won't be on AWS or on Azure, but they're gonna be there, and we can SSH. There's some tools that are even SSH in the boxes and actually running tests within the infrastructure. Then we have security in smoke, performance, and blah, 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 but they all inherent security, which will need a deployed infra and will scan for excesses, how we said, like the problem of, well, I deployed too much. And some security testers cool enough that they can even give you the percentage of respondents to hardening standards. Well, speaking of PCI CSS, DSS, or speaking of ISO 27001. And there are also some tools that do infrastructure compliance, which is kind of nice. Especially, I'm thinking of tools like AWS config, for example. But well, I'll leave this part to Dmitry, that is, yeah, actually craving for telling you all about this. Now, the tools. Are there any tools to do all this, or do we have to bash write the impossible, or Ruby, Python write the impossible? The answer is there are tools, and still we have to write the impossible, because some tools are not exactly mature, but the tools are here. So, sorry for you, this is probably, on this slide, we probably go to stay for 10 minutes, because kind of a lot of information here. So, you can see the colors. So the colors are meaning whether the tool is actually working for Ruby-based languages, such as Chef and Puppet. So that's green. Whether the tool is actually working on Ansible-like syntaxes, so is orange, or whether it's working with Terraform, and in this case is blue. Now, what we see here, we see the three big hexagons with formatters, linters, and spec. Well, this is the difference. These are three different unit testing categories. And each of these tools is actually put onto the category that belongs to the tool. And when they overlap is because a tool can actually overlap one and another. So, let's make an example. Let's talk of Chef. So Chef is based on Ruby, and the first thing we do is we see that there's a tool that is called Rubocop, which is on top left, and is in the section formatters. So what a formatter does is essentially checking that the formatting of the code is correct. Formatting of the code as in, well, I don't know if you know about Terraform format, which remakes the formatting for you and tries to sort the things out, but the format is also, there's not lines that are too long, so when you actually commit them into a repository, they are broken into different lines. So they check the formatting and the style of the code. So it's kind of nice to include, for example, a Rubocop check right before you commit some code, some Ruby-based code onto a repository, because it helps you keep clean and also tells you how to fix some cosmetic, mostly, problems. Then we have linters, and the linters are going a little bit more into the details of the language. So they are actually checking with some syntactical and with more knowledge about the language, what the language should look like and what the software should look like. As in, the typical example is undeclared variables in languages that are allowing you not to declare variables, or I declare the variable and then I don't use it. So clearly this is not a functional problem, but well, this is a warning that I might want to have a look at. So, you know, I've got a variable, I declared it, and then what I'm doing with it. So, and then we have the spec. The specs is the categorization of spec is essentially we define with a definition language, like the one that we saw earlier for TDD, for the TDD of the devs, with the same exact description language, what each piece of infrastructure is meant to do. And then we make the tool verify that our code would essentially do what we have described in the infrastructure. We actually write the test along with the code. Okay, so let's just check an example of some of the things that I've said, and then we eventually come back to this slide. So here you see on the top there's a recipe for installing Apache 2 with Chef. Simple, simple, simple recipe. And then on the bottom you see that first of all I run Rubocop on the recipe, and Rubocop finds two offenses. The first offense is that what I just told you before, which is well, you've declared a variable and you instantiated the variable, and then what are you doing with it? So you're not even using it. And the second one is well, you told me that I should have had the lines maximum length 80 characters, and you're making a line of 88. So these aren't things that are breaking my infrastructure, but well, we might want to address these two. Well, actually they are labeled as offenses, but they are not going to be critical for my infrastructure. After that, I actually run Food Critic, which is a linter, and well, Food Critic is actually telling me, well, look, that your recipe is assuming that somehow you must have a Chef server running, so maybe it's not exactly what you want to do, or well, you probably have to declare somewhere else that you want the server to be running already when you actually run that. So again, it's something that doesn't harm, but you might want to address. Pretty similar stuff with Terraform, for Terraform and Bash enthusiasts. So the thing is, the first script that you see on the top is a script that is actually my script when I'm committing something on a repository with Terraform, which is, well, unless my code is validated and unless all of my files in my descriptions are and in my working directories are formatted properly, well, echo that Terraform files need to be validated, formatted, and tell me the error of validation. So in that case, I had declared two times the www record on Route 53. And so I had to go manually and delete it, and then I had to run Terraform format to fix it before I could actually git push the changes onto the repository. Otherwise, no way, wasn't going to make me commit the stuff. And then in the yellow part, we see that, well, we said that, let's go back to the slide. You see that I'm putting TF format in the formatter area, and I'm putting TF validate on something which is across formatter and linter, but when it's about linter, I'm actually putting TF lint in the linter. So there is this tool which is called TF lint, which is exactly a Terraform linter, and is exactly doing what I'm expecting Terraform linter to do, which is, okay, your code may be correct and might not be issuing problems when you try to validate it, but there's still some things that you might want to address. For example, you remember when I told you that AWS is changing things behind the scenes and you don't know what's going to happen, right? Now, this is not the case because we're talking of a T1 micro down here. Well, the fact is I still have a T1 micro instance in my personal AWS account because I bought a reserved instance 3 years ago, and I'm still up and running. So I'm not going to change it. I'm already paid that. So it's there. But I appreciate it's the previous generation, and so, well, this is a warning, and well, maybe I should one day, when I finish paying it, swap to a T2. And yeah, so also just says it's just a warning, which is it's just a notification. It is beware that if you ever want to add IAM instance profile and you want to run some IAM from within this instance, well, you have to spin it down and up again because it's going to change. It's going to recreate the instance. So these are all informations that, well, they're kind of useful. And essentially, if you put them into a CI/CD pipeline, well, you see that they make your infrastructure development work nicer and smoother. So that was about unit testing. Now, the TDD is something which is inherent mostly to unit testing. So, well, the presentation should stop here, but there's still something that we can do, because if instead of calling it TDD, we were calling it like we were meant to call it at ancient times with the integrated circuits design for testability, well, we can step out of this idea of TDD being bound to unit testing, and we can actually include integration testing. And integration testing is something that is kind of interesting for a reason, which is, well, we have already written, in the case of unit testing, these descriptions here for the spec. By the way, I don't know if you noticed that Ruby and Chef are actually dominating the scene, because all the tools that we're going to find from now on are essentially Ruby-based tools, and all the spec tools are using Ruby as the primary description language. So if you're still in the phase of Python or Ruby, I'm not telling you that you should choose Ruby because I'm a Lambda enthusiast, but this is a good reason to actually also study Ruby. Now, the thing is, well, Chef invested a lot into creating this spec suite, so RSpec, Chef spec, and all the other specs that you're going to see both with me and with Dima later. They're all supposing that you write descriptions of what is going to happen in Ruby. So as you already written the descriptions for testing unit testing spec, why don't we reuse the same descriptions of the behaviors to actually, well, do a functional verification, functional testing using server spec, which, by the way, is yet again based on RSpec, which is yet again based on Ruby. So the description is already written, I just have to patch it a bit, and well, I can reuse it quite effectively with server spec. Then we see that if you're lucky and you work with AWS, somebody wrote also AW spec, which is again server spec with nice libraries for AWS. And so essentially, what this integration testing says is that we are able to run this time the code not on the real AWS environment, but on a simulated AWS environment, not on the real cloud environment, but with an environment which is actually going to be spun up with a vagrant, with a little vagrant architecture onto our machine. And somebody wrote all of the interfaces that are actually making us think, or making our infrastructure tools think that they're actually running on an infrastructure. So one very nice tool that Chef created and sponsored, and they're keeping developing, is kitchen.ci. And well, the cool thing is that, yeah, of course they develop it for themselves, and it works pretty well for their stack of stuff, but they made it open source and so versatile that well, people have started putting out provisioners for Terraform, for example, on Vagrant, and also for Ansible. So now we have a tool which is quite of a killer machine, which is allowing us to actually have integration testing onto Vagrant infrastructure spun on the fly on our machines. Okay, it's not exactly fast, but well, would you want to try your containerized WordPress onto an ECS cluster of 1 million machines on AWS, or do you want to try on 100 machines virtualized onto your PC? So the next step and the next part of the testing is about security testing. And I wouldn't say, but Ruby, Chef, in spec descriptions, and all these are still there. Seems that the world nowadays is dominated, by behavioral descriptions in Ruby. So get the hint, Ruby behavioral description, get the hint. And yeah, but this is something that I will leave Dima tell more about. And there are tools, really nice tools that are actually running on acceptance phase and on real infrastructure spun up on real clouds. One thing that's well, is halfway between security testing and integration testing is the trustable artifact thing, which is, well, we create pipelines, but then we don't verify whether my artifact has been deployed by my Jenkins or by my TeamCity, by my CI engine, or if somebody went into Artifactory and pushed some rubbish. And so I want to actually ensure that what I'm deploying has passed all of the phases of the CI/CD pipeline process and the testing. So the thing that I can think of is, well, let's start deploying artifacts and deployable things that have got a signature which is actually passed across all the steps of the pipeline, so that the deployment engine is able to recognize what has been produced automatically and what has been tried to be sneaked in. And well, this is a pretty simple approach, but it's just for giving an example. And then the last thing is compliance. So there's no security without compliance, and yes, the sign artifacts deployment is part of the compliance. So now we have an infrastructure. We have deployed an infrastructure, and as a code, and so we are assuming that everything is up and running. It's a big assumption. And what if somebody's SSHing the machines and is making some disasters, and I don't know, and I'm assuming that something is wrong with the instance. But so to ensure, especially in certified environments, and when we cope with banking or with some important transaction holders, that the infrastructure is staying in the way that we actually have deployed it, we can use tools. And well, I'm actually posing your attention of AWS config, which is the compliance verification infrastructure tool from AWS, which, well, you give AWS config the description of how the infrastructure is going to look like with the set of rules, and this keeps polling the infrastructure and checking that the infrastructure remains the way that you wanted it to be. It's pretty cool. In case this is not how you would have wanted to deploy, it's triggering a very nice event that you can catch with Lambda, and you can actually respond to the event. So this is yet another of the things that we can have a box running in an AWS account. But I'm talking about AWS, but and instead of having that to ping, we can actually react to some modifications. But this is just yet another idea that can be put into the testing the infrastructure as a code. So, well, this is an example of a coordinated test strategy, which is looking extremely like the branching strategy of the devs, and with the tests of the devs, and is no surprise, because we are actually doing the same, and as you've seen, we can do unit testing early in the build of the feature and merging into development. Then we can have integration tests when we're actually merging onto the release, and then we can have acceptance tests when we're actually merging onto the master. And in how Terraform used to do, technically what is in the master should be the copy of what is in production. So essentially, what to do next? To do next is, well, we have seen that the tools are there. They're not exactly great, but, well, they're enough to create a pipeline. We've done better with less tools, with worse tools, and now we have something, and at least there is a clear idea. The clear idea is that learn Ruby to create descriptions of what is meant to be, because there's no other way to actually create descriptions. And the second thing is, so spread the voice, and we want DevOps to test their stuff, because, well, we can do the things in a proper way, and we have to show these people that want DevOps just as expensive parts of their companies, to see that we make the difference, and we make them save money, and so they can pay us more. The second thing is develop and share the tools, and, well, share the tools, share them. And the third is, well, let's build best practices and spread the best practices, because, well, if you do it 3 times, you need to automate it. If you do it, if you automate it, you need to have it tested. And this is something that we have to have clear in our minds, and we want to be better DevOps and deploy better infrastructures. So thanks for your attention, and well, thank you.